Okay, Assalamualaikum and good day to all. So we are going to continue our topic 3, which is kinematic in one dimension. Okay, before this, we discussed about the displacement distance, average velocity, speed, instantaneous velocity, acceleration, and average accelerations. Now we are going for application questions where we are going to be introduced to the equation, four main equation, which this equation have a constant acceleration, and then after that we are going for free falling object, where we are going to discuss about motion in y-axis. Okay, let's start. Okay, so basically before we proceed with the how to use the equations, we need to know how to derive the equations. So in front of you, you can actually see that all the symbol that we are going to use in this equation. Okay, so because now we are discussing about x component, okay, which means motion in x component, so that's why we are going to use the s as your position. So not here, or we can call 0 over there, t0 or t0, basically an initial point. So without any naught or without any 0, we call as a final position, final one. Okay, so not the initial one, without naught means final. Okay. So now we are discussing about motion that moving at a constant acceleration, which means that at this particular time, instantaneous acceleration will be equal to the average acceleration. Okay, so in front of you, we have four equations. With this equation only can be valid for acceleration, they are constant. Okay, so how to get this formula, how to get these equations, you need to know how to derive it, because the questions because it can be in your test where we ask you to derive. Okay, so let's start with the derivation. Okay, so for the first part, we are going to start with average acceleration, which is basically equals with the same as the instantaneous acceleration. So means that average acceleration, what is the formula? It should be a, okay, I'm not going to put bar over there, because instantaneous acceleration will be equal to the average acceleration. So the average acceleration is basically v final minus with the v initial divided by time. So here you are going to choose your t0 or your initial time as 0. So you are going to get a equals to v minus v0 over t. So rearrange the equation, so you are going to get v equals to v0 plus at. So this one going to be the first equation that you are going to get. Okay, second equation. Okay, when velocity increase at uniform rate, velocity increases at uniform rate. Okay, so means that your average velocity will be in the midway between initial and final velocity. Okay, so means that your velocity, example, increases 2 meters per second every each 1 second. So means that your velocity going to increase at uniform rate, which means that your average velocity here, the formula going to be v bar v final plus with the v initial divided by 2. Okay, so you are going to get the second equation. Okay, now we are going to derive for the third one. Okay, so the derivation for the third one going to be start with the average velocity. Okay, so this is another formula for the average velocity, which is basically the velocity increases at uniform rate. It will be midway between initial and final. Another formula for the average velocity is going to be v bar equals to x minus x final minus x initial divided by time. Okay, so, or we can actually say that the change of position divided by time, displacement over time. So rearrange first the equation where you get x minus x naught v bar t. Okay, and next is you are going to take this one, and then you are going to put it inside the V bar. Okay, so it's going to be, okay, x minus x naught equals to v plus v naught over 2t. Okay, okay. So next we are going to put the v here which means that we are going to take it from here. Okay, so it means that you are going to insert this v bar into this formula. Okay, so what you are going to get, so you are going to get x minus x naught equals to v naught plus at plus v naught over 2t. Okay, and then expand the equations, then you are going to get here is 2v naught t over 2 plus at squared over 2. So this one can be cancelled. So at the end you are going to get the third equations, where s minus s naught v naught t plus half at squared. Okay, okay, for you to get the fourth one, okay, for you to get the fourth one, you need to use the equation starting from here. Okay, so okay, for the fourth one, okay, this is the third one, sorry, this is the third one. Okay, okay, for the fourth one you need to use from there, which mean that okay, I'm going to rewrite it again. S equals to s minus naught v plus v naught over 2t. Okay, before this we insert into v, now we are going to insert into t. So we are going to use this one and then put it inside t. Okay, so this formula you need to make your t as a subject. Okay, so I'm going to put it here. So t is going to be equals v minus v naught over a. Okay, so once you're done with this, you insert this one into, substitute into t. So you are going to get x minus x naught v plus v naught over 2, and this is going to be v minus v naught over a. Okay, so okay, so expand the equations, then you are going to get x equals to x naught, okay, equals to v square minus v naught v plus v naught v minus v naught square over 2a. Okay, so after that you are going to get here is x minus x naught. This one is going to be 0, so you are going to get v square minus v naught square over 2a. Okay, so rearrange everything, then you are going to get v square equals to v naught square plus 2a x minus x naught. Okay, so this is going to be the equation number 4. Okay, so that's how you derive it. Okay, okay, so you are going to get 4 formula here, which means one is v equals to v naught plus at. Okay, second is v bar equals to v final minus plus v initial divided by 2. The third one going to be this one, which is s minus s naught v naught t plus half at squared, and the last one going to be v square equals to v naught square plus 2a s minus s naught. Okay, so I hope you can practice for this part of derivation. Okay, okay, so basically we have 4 formula. So how to use that formula? Okay, so I'm going to rewrite again all the formula that we are going to use. Okay, so we have 4 formula here, where the first one is v equals to v naught plus at. Okay, the second one is v bar, v final plus v initial divided by 2. Okay, the third one is x minus x naught v naught t plus half at square. This is going to be the one. And number 4 going to be v square equals to v naught square plus 2a x minus x naught. So this is going to be number 4. Okay, for you to use this formula, okay, first thing first is I encouraging my students to rewrite again all the formula, and then after that, when you read the questions, you extract all the important informations, okay. So and then you need to identify whether it's going to be the final velocity, whether it's going to be the initial velocity, whether that one is going to be time, okay, whether it's going to be initial position or final position, okay. So like in front of you we have a questions which are you are designing an airport for small plane. One kind of airplane that might use this airfield must reach a speed before takeoff at least 27.8 meter per second, okay, and can accelerate at 2 meter per second square. Please take note, the questions the formula can only be used for constant acceleration, okay. If the runway is 150 meter long, can this airplane reach the required speed for the takeoff? So the question asks you for initial velocity or final velocity. Yes, the question asks you for final velocity, okay. It means that if your airplane reach the required speed, which is your required speed is what, 27.8, then it can be take off, okay. So means that you need to find the final velocity. Right now they already give you the acceleration, they already give you the final positions. Mostly for the initial we can actually put it as a 0 here, so you need to find the final velocity. So which formula from these four can be used? Okay, so I think the first formula cannot be used because you don't have information for the time, okay. For the second one, you cannot use that because you need to find the average velocity first, and then you need to insert that into the another equation, which is quite tedious, okay. How about the third one? Yes, you can use that one too because you need to have time, and I think the best one going to be number 4, okay. That's how you identify which equation for that particular questions. But please remember that sometimes the questions can be solved with 2 or 3 equations. It means that you can actually solve using 2 different equations for the equations. It depends, okay. So we are going to use the number 4 equations. We are going to put it as a v square equals to v naught square plus 2a x minus s naught, okay. Sorry, going to okay. So v square is something that unknown here, so v naught square I put it as 0 because the airplane start from 0, okay, and the acceleration is 2, final position is 150 meter, and then initial going to be 0. So your v here, square root everything, supposedly you are going to get 24.5 meter per second, okay. And then next question, okay, next question is, the question asks you, if not, okay, right now you get 24.5 meter per second, which means that it's not the required speed to take off. So means that this airplane definitely will not take off, okay. So what is the minimum length for the question, for the next question, required to make sure that at least this airplane have speed of 27.8? Okay, means that right now the question asks you to find length, okay, but you need to use the velocity here, okay. So I think the best formula definitely going to be the fourth one, which is the same formula, but now you are going to find the s instead of v, okay. So make sure that you always write your formula before you start your calculations, okay, because somehow maybe you are going to get marks, okay. So v square is 27.8 square, and initial going to be 0, the acceleration is going to be 2, your final you didn't know, and your initial going to be 0, okay. So you calculate that, then supposedly you are going to get your final position is s equals to 193 meter. Okay, easy, right? Okay, so basically the trick for this kind of question is, the first thing you need to extract all the information given, identify which symbol represent the information, whether it's acceleration, whether it's final velocity, initial velocity, whether it's initial position or final position, whether it's time. Okay, and after that you compare with the formula, with the four formula that you learn how to derive before. Okay, so from there, so basically the questions can be solved with, maybe you have 2 or 3 equations. Okay, depends. Okay, let's move with the next question. Okay, so how long does it take for the car to cross a 30-meter wide intersection after light turn greens if the car accelerates from rest? So definitely we're not going to be 0. Extract all the information given at a constant 2 meter per second square. Okay, the question asks you to find how long, which definitely you need to find time. Okay, so for this kind of questions, okay, which formula that you are going to use? Okay, whether is V equals to V naught plus AT, whether is V bar equals to V naught plus V over 2, whether is X minus X naught V naught T plus half AT square, whether is V square equals to V naught square plus 2AX minus S naught. Okay, but the question asks to find how long. Definitely from these 4, the only equation that have time in their formula is going to be this one and this one. Okay, so which one between these 2 that you can actually use? Okay, you already have here is your displacement, which is as your final position is 30 and your initial is 0. Okay, and then you don't have your final velocity there, so definitely this one out. Okay, so it means that you are going to use this one. Okay, so you take that formula, X minus X naught V naught T plus half AT square. Okay, so your initial going to be 0, so this one going to be 30 meter. Initial what? From rest. Very good, so it's going to be 0 over there, plus 1 over 2. Acceleration is 2 meter per second square, T square. So you are going to get your T is 5.48 second. Make sure your final answer, you put the units there. Okay, got it? Okay, so there's the rest of the questions that are already prepared in the slide, so please do that questions and we are going to discuss during class session. Okay, so let's proceed with the motion in y-axis. Okay, when we talk about free fall object, definitely these objects are going to be influenced by gravitational acceleration. Okay, so now acceleration. Okay, so basically what happened here is all the object in this world will be affected with the same g. Okay, which is the value of the g going to be 9.80 meter per second square, or you can actually use as 9.81 meter per second square. Okay, and then the things that you need to understand here also, okay, at the given location on Earth, all the object here, we are going to assume there's no air resistance. Okay, if there are air resistance, definitely the calculation going to be tricky, going to be harder. Okay, but this one we assume that there's no air resistance. Okay, which means that the object all fall with the same constant acceleration. Okay, because all object will fall with the same constant acceleration. That's the reason why we can actually use 4 formula that we derived before. Okay, and then you can see from here, okay, the photograph, the apple falls further during each successive thing interval, which means that it's going to be accelerating. Okay, you can see that there's a change in definitely velocity. Definitely they will be accelerating. So the accelerating here means that it's going to fall with value of g equals to 9.80 second meter per second square. Okay, Okay, and that's why if you release two objects with different weight, with different weight, in the absence of air resistance, basically what happened is going to reach at the surface at the same time. Okay, but you need to understand that with the absence of air resistance, because of why? Because both are accelerating with the same g. That's why it's going to reach at the same time on the surface, on the ground. Okay. Okay, so this is basically another experiment that prove you have a feather, you have a rock over there. When you actually put it inside the space with the absence of air resistance, it's going to reach at that same time. Okay, because these two objects are going to fall with the same constant acceleration, which is, what is your constant acceleration? Is going to be your g. Okay, 9.80 meter per second square, or you can actually use 9.81 meter per second square. Okay, so basically we are talking about some object that are in vertical motions, which means that in the previous formula we use x, now we are going to use y. Okay, and then it's up to you. You can choose your upward as positive, or you can choose your downward as positive. It's up to you. It's basically arbitrary. Okay, you can choose upward as positive or downward as positive. It's up to you, but I think most of the students going to choose upward as positive, downward as negative. Okay, but if you want to be different, you can actually make it vice versa. It's up to you. Okay, so basically when it comes to the formula itself, so all the formula, basically you are going to use the same formula, okay, without the second one. Okay, for the second one, which is v bar equals to v naught plus v over 2. This one is rarely used. Okay, so you can actually see that most of it we are going to use the 3 formula instead of this one. Okay, so the 3 formula here, when I change the x into y, so it become v equals to v naught plus at. Okay, so now your a here will be value of g. Okay, please, if I ask you what is the acceleration, okay, you are going to state is gravitational acceleration. Okay, gravitational acceleration. Okay, and what is the value of g? Is going to be 9.80 meter per second square. Don't put negative over there, because negative can be upward, it can be downward. So please put 9.80 meter per second square, and acceleration is vector, so please state acceleration always be downward. Okay, always be downward. Okay, so here, if example you assume downward is negative, so means that your formula here going to be v equals to v naught minus gt. But I prefer to put the original formula first, and when I do the calculation, I put the negative 9.80. Okay, it's much easy, and you are going to avoid confusing when it comes to sign. Okay, next, v square equals to v naught plus 2ay minus y naught. Okay, because we already changed into y position, and your a here is g, and the last one going to be y minus y naught v naught t plus half a t square. Okay, yes. Okay, so please decide your directions, whether it's upward is positive or downward is positive. Okay, because it's going to change, because you need to be extra careful when it comes to the sign. Okay, so example, if I give you one situations where you have one object, okay, it means that, okay, this is you throw the object basically like that. Okay, supposedly the object going to like exactly fall in the same place, but when we expand this picture, it's going to be like that. Okay, it's going to be like that. Okay, so what happened here is, okay, when you throw the object upward, means that you are going to move your hand upward, right? So at that particular time, okay, I'm going to like draw it again to make it much more easy. Okay, this is you. Okay, and then you throw it upward like that. Okay, you throw upward. Your initial velocity at this particular time going to be positive, because you can see that the motion of your hand is upward. And please make sure that before you decide your sign, please choose your reference point. So I'm going to choose my hand as my reference point. Okay, reference point means that I'm going to put it here as my y not going to be 0. Okay, so means that everything above the reference point, everything moving above reference point, I put it as a positive. Everything below or moving below the reference point is going to be negative. Okay, that's why first step, you need to decide your reference point. Okay, so when you throw the object up, what happen is you are going to move your hand above the reference point. So what happened? Your velocity going to be positive. Okay, very good. Okay, when you reach, okay, the highest point, or we can actually say that maximum point, highest point or maximum point. Okay, is there any acceleration? Yes. Okay, your acceleration is value of g. Is there any velocity? The velocity over there going to be 0. Why? Okay, because if you expand this picture a little bit, you can see that at the highest point, okay, it's moving like this, which means that at this particular point, the only thing that have is vs. Okay, and your because you can see that it's move in horizontal direction. Okay, so your vy here going to be 0. Now we are talking about free fall. That's the reason why your your maximum velocity, your velocity at maximum point going to be vy equal to 0. So how about vs? That's one going to be discussed in the projectile motion. Okay, so please take note, at the highest point or the maximum point, your vy going to be 0, because we talk about free fall, which is in y position. Okay, good. Okay, so when the object moving downward, and then reach at the same point when you throw the object, what is the value of velocity? Okay, because it's moving downward, you can see that is moving downward, basically downward. At this particular point, your velocity here going to be negative, because it's pointing downward. Okay, you can actually say that if the object pointing downward, then it's become negative. Okay, then what happened if the object passing through the reference point? What is the velocity here? Same, the velocity here also be negative. But what is the velocity when it reach the ground? Okay, here we couldn't find the velocity here. Why? It's not 0. Okay, because the moment the object reach the surface, it's not going to stop immediately. Okay, so means that if you want to find the velocity over there, you need to take into account the friction, the pressure, the force applied from the surface to the object. That's the reason why most of the question will be asked, what is the velocity before it reached the ground? Before the object reached the ground. Okay, because it's very impossible for you to find the velocity exactly at the ground, because the object not going to stop immediately when it reached the ground. Okay, that's the reason why you can see that most of the questions state before it reached the ground. Okay, so from this picture itself, you can see that there's a deceleration and acceleration. Where? Okay, when you throw the object upward, okay, that's why you get the positive here. Okay, but what is the value of your g? What is the direction of your g? Like I mentioned before, always be downward. So your g always be downward. That's why you're going to put negative in your answer, in your equation. Okay, and then it goes upward up until it reach the highest point or maximum point. What is the value of g? Yes, it's going to be is going to be negative g, because why? Gravitational acceleration always pointed downward. Okay, but when the object moving downward at this particular point, what is the value of g? What is the sign of g? It will become, yes, negative g, because gravitational acceleration always moving downward. Okay, the reason why I always state downward is because I don't want you to confuse when it comes to the sign. Okay, please take note, gravitational acceleration always be downward. Okay, if you choose your downward as positive, that means your g will be positive. If you choose your downward as negative, then your g will be negative. Okay, it's very important for you to identify which sign that can you use, or which sign that you need to use, because it's going to affect your calculations. Okay, so as you can see that, like I mentioned before, there's a acceleration and deceleration at this particular point. Okay, you can see that. What does it mean by deceleration? Okay, slow down. Okay, very good. The directions of A and V will be opposite. Okay, very good. Okay, so between number 1 and number 2 point, which one is deceleration, which one is acceleration? Yes, good. Okay, this one will be deceleration. Why? Because your V is upward, your G is downward, which is basically obey the condition for deceleration. Okay. And this part going to be acceleration. Okay, because acceleration means that velocity is increasing, so your V is downward, your G is downward, moving in the same direction. So that's why we call as a acceleration. Okay, got it? Okay, good. Okay, let's move with the question. Okay, so you can see that in the question itself, there's a answer there, but just ignore the answer. Okay, you don't have to follow the sign that the question is given to you. You can choose your sign by yourself. Okay, so the question asks you to find how far will it have fallen after a time t 1 second, 2 second, and t 3 second. Ignore air resistance. Okay, when means that when the question state ignore air resistance, means that all the object going to fall with the same g. Okay, so the question asks you to find how far, which is definitely the question asks you about final position at 1 second, 2 second, and t 3 second. So between that three formula, which one you need to use? Okay, v square equals to v naught square plus 2ay minus y naught. Okay, y naught, or v equals to v naught plus at, or y minus y naught v naught t plus half at square. Which one? Definitely you are going to use the third one, because you have been given time, you know acceleration is value of g. I'm going to use 9.81 meter per second square. Okay, and then what is the initial velocity? Because you drop, when you drop the object, your v naught will be 0. If you throw the object, because your hand is moving, definitely there will be a velocity over there. Okay, remember, when you drop the object, it means 0. When you throw, definitely there will be a velocity. Okay, and then how far? Okay, so means that we just insert that into the formula. So why not here? I'm going to put as 0 because I assume that this is my reference point. That's why I'm going to put this as a y not equal to 0. Okay. Please make sure that you choose your correct reference point because you are going to decide your sign. Okay. So y minus 0 equals to v naught because it's dropped. So it's going to be 0 plus 1 over 2. What is the value of a? Then I'm going to put negative here because it's downward, because your G always moving downward. 9.81. T going to be 1 second square. So you are going to get your answer is 4.90 meter. Okay. So you do the same thing for the rest of y2, where you are going to get your answer is 19.6 meter. Oh, forget. You are going to get negative here. It is correct? Yes, it's correct because your position now is below the reference point. That's why you are going to get your y final position is negative. Okay? If you choose below the reference point is positive, then you are going to get positive answer. Okay? So now I'm going to get negative answer here. And my y3, I also get negative, which is 44.1 meter. Okay? That's how you do it. Okay? Just be extra careful with the sign and make sure that you choose your reference point first before you start your calculations. Okay, let's proceed to the next one. Okay, so in front of you, we have another questions where the question state that is throw downward, okay, with initial velocity of 3 meter per second. So means that when you throw downward, definitely you have a velocity over there. So this one going to be your initial velocity, okay. What then would be its position after 1 second and t 3 seconds? So you need to find the final y. So which formula that's basically suitable for these questions? Yes, like previous one. So we are going to use y minus y naught v naught t plus half at square. Okay, so I'm going to choose the moment it throw downward as my initial point. So this one going to be 0. Okay. And then I need to find y here. Okay, so because it's throw downward, okay, when you throw downward, okay, your hand is basically below than your reference point. So means that at this particular point, your initial velocity will be negative because it's below the reference point. Plus, plus the directions of the velocity at a particular time is downward, right? So you need to put negative here. Yeah, okay. So that's why I say that before, please be extra careful with the sign. Okay, so time is 1 plus 1 over 2. Because I'm choose my downward as negative, that's why my A or my or gravitational acceleration going to be negative. Okay, and then t there is 1 square. Supposedly you are going to get your answer is negative 7.90 meter, which is correct because now because the position is below than your reference point, that's why you are going to get negative value. Okay, you are going to repeat the same step with the same formula. Okay, for y2 seconds, supposedly you are going to get your answer is negative 25.6 meter. Okay. Okay, so let's proceed to the next one. What would its speed be after 1 second and 2 seconds? Okay, the question asks you about speed. So basically, you are not going to use the same formula because there's no speed in this formula. Okay, so you need to use another formula that have speed there, and also time and also initial velocity. So I think the best formula would be v equals to v naught plus at, because the question asks you about speed, which is final velocity. Okay, so here we need to find v naught is what? Negative 3 because you throw downward. Okay, if you throw upward, then it's going to become positive. If you throw downward, because below the reference point, then it's going to be negative. Plus my a definitely going to be negative. Okay, and t is 1 second. Okay, so supposedly you are going to get 1 plus 3. You are going to get negative 12.81 meter per second, which is correct because right now the object is moving downward. That's why you are going to get your final velocity is negative because it's below than reference point. Okay, then you do the same thing for your v 2 seconds. So supposedly you are going to get here is 2 over there. So you are going to get 1 times 2 plus 3. So you're going to get negative 22.62 meter per second. Okay, the question asks you to draw compare with the drop ball. So the answer given here is basically the answer for the drop ball. Okay, so the same thing, the same formula that you are going to use. Okay, so you are going to get you are going to use v equals to v naught plus at. Okay, so we are going to find for the drop ball. Drop ball means what? Yes, very good. V initial going to be 0. So v equals to 0 plus negative 9.81 t. So you are going to get your v is negative 9.81 meter per second. Okay, sorry. Okay, and then this is 1. Okay, I'm going to continue with the v2. So the same formula, v naught plus at. Okay, so v for the 2 seconds going to be v naught is 0, okay, because it's dropped, plus negative 9.81 times 2. So you are going to get negative 19.6 meter per second. So based on this answer, what you can actually say that? You can say that when you throw the ball, the speed is going to be increases. The velocity going to be increases, okay, in compare with the drop ball, because you give some push, you give some force at the initial position. That's the reason why you are going to get the value for the speed, final speed, will be higher for the throw one instead of the drop one. Okay, got it? Okay, very good. Okay, I think I already prepare lots of questions when it comes to the free fall in the original slide. Okay, you can do that first, and then we are going to discuss during our class session. Okay, so please try your best. If you have any problems, feel free to ask. Okay, so I'm going to see you during class session. So thank you very much. Assalamualaikum. Bye bye.